Hello there and welcome to the next video. In this video, I'm gonna explain you the basic things in terms of UI designs and screen resolutions as well as DPI. This might be helpful also for those of you who already work with UI, and I believe that there is a lot of confusion over this topic in the web, so I'll try to put it as simple as possible and give you some handy takeaways. Okay, let's begin with the basics, and those are three terms: screen size, screen resolution, and screen density. So those are pretty easy and straightforward, and I bet you know them already. So the screen size is the diagonal of the screen measured in inches. So if you take the ruler and you put it to the screen like this, you have the diagonal of the screen that is basically its size, and this might be 11 inches, 15 inches, or for example 27 inches. Then you have the screen's resolution, and this is measured in pixels. So you have the resolution's name, for example 4K or Full HD, but always you have also the count in pixels for width and height. So for example, for Full HD screen, you have 1920 pixels there, and you have 1080 pixels height. So no matter the name, you always have those lines and those pixels that are to the width and height of the screen. Then you have the density, and this might be the most complicated of them all, because to know the density, you have to know the screen size and the resolution. And density is simply the number of pixels that are packed in 1 inch of a screen. So you might have a larger density number, and then you have more pixels in 1 physical inch of the screen, and you might have smaller number, and then you have less pixels in 1 physical inch. It also means that if you have smaller number in density, you will have larger pixels on the screen. So physically, they will be bigger on the screen. And if you have a large number in density, you will have very small pixels. And this basically is what we need to remember when we create graphic assets. So let me put it to this screen. Well, we have the screen size of 27 inches, then we have the resolution of 4K, and here we have the density, which in this case is 163 ppi. So I'm talking about ppi, and what's the difference between dpi and ppi? Well, this is fairly simple, and those values are similar. You can think of dpi as more connected to the print, because this is dots per inch, and it means that you have these little dots falling out of the printer to the paper, while on the screen, the smallest part of the screen is simply pixel, and this is why we use ppi, and this is simply pixels per inch. So we'll use ppi from now on, and this is the amount of pixels that are in the 1 inch of the screen. And if you take 1 square inch, you will have, for example, for density of 160, you will have 160 pixels wide and 160 pixels tall. Okay, so that's pretty easy, and now you can count the density as well as the other values. So you need to have resolution and also the screen size, and if you divide those values, you get the approximate number of screen density. Well, this is approximate and it's not mathematically perfect, but you can get the estimate. For example, for this 4K display, which is 3840, if you divide it by the screen size, so 27 inches, you get approximate of 140 density, and this is actually 163 ppi if you use the calculator that I provided you link to, and I encourage you to use this calculator, but you can get the idea of how packed are the pixels inside of 1 inch. Of course, it's better for the user to have more ppi, and this is simply because the image is crisper. Pixels are smaller, and that's why everything he sees is crisper and extremely sharp. You might recall some low numbers of density, for example 72, and this is the value that still exists in Photoshop, by the way. But from the Photoshop, if you take Photoshop apart, well, there's no screen that has 72 ppi anymore. Well, those were first Macs with those 72 ppi. Then we have higher resolutions like 96 or over 100, or even 400 and 500 dpi's for the newest devices such as new iPhones or Samsung devices. And this is pretty crucial and it has an impact on our design. But I'll explain you that in a second. Okay, now let's conclude some things. So resolution itself does not contain information about sharpness, and so does the screen size. So if I provide you with resolution which is full HD, for example, you can't really tell that this screen is, for example, good quality or bad quality. You have the amount of pixels, but you can't really tell the density. The same happens for the screen size. If I tell you that I have a small screen size, you can't really tell if the density is good enough or bad enough, okay? So you have to have both values. So if, for example, I tell you that I have full HD display and nothing more, well, I can have full HD display on the phone and then I have a large density number and it's crisp. But then you can go to the cinema and you have the same full HD screen, which is displayed across maybe 200 or 300 inch screen. And this will be of a lower value of density. Well, in the cinema, the trick is that you are further away from the screen and you can see the crisp details. But if you go closely to the screen, you will see that you can see individual pixels and they are pretty large. So as far as UI design is concerned, we have to think about people that are close to the screen, and that is why we need high density screens. Some people say that 300 dpi and 300 ppi is quite enough, because 300 you might know this value from print. It's common for print and print is pretty crisp. So if you have 300 ppi for the screen, it's really okay. But I think you can notice the difference between 300 and, for example, 450. Okay, so you have to know the PPI to get the idea of how sharp and how crisp the screen is. And getting the resolution itself or the screen size itself doesn't determine that this is sharp or not. Okay, now this has an implication for the design we create, because you might think that if you take pixels as a value and you always take pixels as a value for a screen design. So if you have, for example, an asset that is 100 by 100 pixels, you might imagine that on the lower quality screen with lower PPI value, this asset physically on the screen, when you take a ruler, it appears larger than the one that is displayed on very high quality display where the pixels are very tiny, but still this is 100 by 100 pixels, so a fixed size. So if you have smaller pixels, you will have a difference in this physical size when you take the ruler and measure it on the screen. Well, it might appear like this, but it's not entirely true. And to understand it clearly, we have to go back in time, and in our time machine, we have to go back to iPhone 3GS and our iPhone 4S, which was the first one with Retina display. Well, Retina is this better display, and now we have even Super Retina, which I'll mention later, but let's focus on this example. So iPhone 3GS and 4S were the same in size. I mean the physical size, the dimension of them were both 3.5 inches. So the screen is the same size if you take the ruler and measure them physically. But then you have different values of pixels, because in 3GS you have 480 by 320 and in 4S you have 960 by 640. And this is exactly twice the amount. Well, so if you have twice the resolution, you have 4 times as many pixels in the screen, meaning that for 1 pixel in iPhone 3GS, you have 4 pixels in iPhone 4S, or in other words, you have pixels that is 4 times smaller on this better screen. So you might think that if you create an asset that is, for example, I don't know, 150 by 150, and you put it to iPhone 3S, it will appear almost at the half of the screen. And then on iPhone 4, it will take only a quarter. But this is not entirely true. This is simply because those devices will try to adapt so that the physical size of the objects that you create, the assets that you put into your design, is similar. So that if you take a ruler and again measure it on the screen physically, they try to create assets that will be the same, approximately the same size. So the answer for this question is resizing. And the resizing value here is 2 times. And this is simply because we have twice the resolution, so that we have to enlarge this element 2 times so that physically it appears the same to the user. It's pretty cool for the user because it means that if you have the same asset, 100 by 100 pixels, it will always be, for example, 2 inches by 2 inches on the screen, no matter how good is your screen. But on this better quality Retina screen, it will be also sharper. But this means that you provided vector assets and those were scaled. They scale seamlessly to different resolutions and are extremely sharp. But if you provide bitmap assets, then those bitmaps can be scaled even up to 4 times, and you can have a result of scaling from 100 by 100 to 400 by 400 pixels. And even though the size physically on the screens might be similar, you will notice the difference, and on this higher quality screen, this scaled bitmap will appear blurry and it will be of poor quality. So the solution for that is providing vectors, but also we can create multiple assets that will produce and then export for multiple scale factors. I'll show you that in a second. For now, let's go back for just a moment to this display properties on Mac. So it's natural that when you change the resolution, please take a look at this window. If you change the resolution, you will have the window smaller if you go higher in resolution, and this is simply because pixels are smaller. And also if you go up, you will have a bigger window, and this is because pixels are bigger. Well, it says that it looks like 1600 by 900. And yes, it looks like because it's somehow fake, because you can't really put pixels outside of the screen. It will also only be fake scaling that you can apply to this display. But still underneath, it will have this maybe 200 dpi, for example, and it will be extremely crisp. So in the system, you can basically set the scaling yourself, but the scaling is also applied by the OS itself. So the system decides that it will automatically scale your content no matter what. So this multiplier is an OS thing. It will scale everything that you provide, whether it's a native app or, for example, a web app inside of a browser, and it will scale it up by this multiplier. So the multipliers are different, and the general rule is that if you have higher density for the screen, you'll have the higher multiplier, so that you can compensate for the smaller pixels and you can display similar size in physical size of those assets that you create. So for example, for iOS, you have multipliers 1x, and then you have the scale of 2x for all the Retina displays. And also for those super Retina displays, you have 3x. For example, for iPhone 10 or for iPhone 8 Plus, they will scale 3 times. And for Windows, you have even weirder scales, for example, 1.4, 1.6, or 2.25. For Windows Phone. And then you have Android multipliers, which start even lower from 0.75, and then you have 1.5, 2x, 4x, and even 4x. So Android has special names for those scales, and you have, for example, medium DPIs or X DPIs or XXX HDPIs, and those are basically the names for the scales. And this is not all that important for you, but basically if you want to know how it determines whether to apply this or that kind of scaling, is dependent on the density of the screen. So if you have higher density, so for example, for Android, it falls for a different density bucket, for example, from density 300 and up, and then it decides to scale it, I don't know, maybe 3 times, okay? So you have these different multipliers, and it means that everything that you provide as an asset will be scaled. So if you provide, for example, a button that has 44 by 44 pixels and then 8 pixels padding at each side and then 16 pixels font and also 4 pixels rounded corners, it means that for the Retina display that scales 2x, it will go to 88 pixels wide and tall, and then 16 pixels paddings, 32 pixel font size, and 8 pixel rounded corners. So everything will be scaled accordingly. So if you have bitmaps and you need to export JPEGs and PNG files, you will have to create assets for each multiplier you want to cover. So for example, if you want to cover all iOS, you have the sizes of 1x, then you have 2x, which is double the size, and 3x, which is triple the size. For Android, you can even go to 4x. And the ultimate design question is whether we start from this initial 1x scale, or for example, native scale for, I don't know, iPhone 10, which is 1125 by 2436. And the answer is you always start with 1x scale. And there are many reasons behind that decision, but it's always easier to start small and then export your assets if you need them to be exported in higher scales. And you only need them to be exported if you have bitmaps. For vector files, you are completely safe. So working in 1x scale is easier. This is simply because you don't have to count the values. If you scale upwards, you have 100 by 100 asset, for example, and you want to scale 3 times, it's as easy as having it 3x, it will be 300 by 300, and as opposed to the situation where you have 100 by 100 asset in the 3x scale, and then you need to export to 1x. Then you have to divide by 3, and you get something like 33.333, and this is not good. If you have sub-pixel values that will not be perfectly aligned to the pixel grid, you will be in trouble. This is simply because this pixel will be blurry on the screen. Screen has full pixel, and full pixel can only display one color. So if you have half of the pixel value, you will have a blurry line instead of a nice sharp edge. So this is great when you work with 1x scale. And it also keeps the files smaller. So you don't have those huge files with huge resolutions, and when you go to 100%, you will see this huge screen, and then you want to put everything inside this large area, and then when you try to preview that on the device, you see that everything is so small, okay? So it's also always best to have this 100% preview approximately the size of the device on the screen. So if you go to 100% in Photoshop or in Sketch, you see the size of approximately the device that you're creating. And this is usually with 1x scale, not the bigger scale that you work with. Okay, so you might think now that there is such a pain in all those scale factors that you have to export all the sizes, but to be honest, you don't have to. You just need to work in vector environment. And then you are safe, because if you want to export these assets, it's just one click in Sketch or in Photoshop or in Illustrator, and simply you export bigger assets. And if you don't have vectors, then there is a problem. And the only one situation that you don't have vectors for UI design is photos. Well, cameras don't yet take pictures as vectors. And this is why you have to have bitmaps for photos. And for the photos, you need to have those different scale factors. But then again, if you start with the smaller scale, it's so easy to export them, and it's only one click inside of Sketch. Let me show you how it works. So if you go, for example, to Sketch, you will then have to select the asset, and then you go to make exportable option. And here you have the size and the scale. So you always think of a scale as a designer. You don't think about DPIs or anything like this. You always think of a scale. So if you design in 1x scale, it means that you started your work with 1x scale, for example, for an iPhone, which in our case was about 375 by 812. Then you always have to export in bigger scale. So for example, you can add more scales like 2x and 3x for these assets and simply export it, and it's all you need to do. But if this is vector instead, it's so much easier, because you don't need any scales than one. So you simply change the extension, and you select SVG, for example. We'll talk about it in a second. Then you don't want any suffix or prefix here. And the conclusion is that vectors are your best friend, and all modern UIs are vector-based, and the only one situation when you have to deal with those scales and export in different scales is when you work with photos. Well, Cameras doesn't yet take vector images, and so you always have to have this bitmap image as a photo. So the most important thing is that you keep this as high resolution as possible and you bring it to Sketch in high resolution, then you scale it down and you are safe to export in 1x, 2x, 3x, even 4x, because it will always go to the original file and check the resolution and then export it in its native resolution if possible, okay? For Photoshop, you can do the same, but in Photoshop instead you have to create smart objects. I bet that you know this convention. Well, if you import anything into Photoshop, you first need to take care that and make sure that this is basically a smart object. And if it doesn't, for example, if it's simply a raster layer, you have to convert it to smart object before sizing it down. If you do so, and you have the native resolution inside of the smart object, then you can go and right click on this layer and select export as, and then you'll also be able to export in scales. Then if you select another scale here, for example 2x or 3x, this will go to the smart object inside the smart object, grab the resolution, and it will have this native resolution, and it will be extremely sharp and crisp. So you can do it like this in Photoshop using smart objects, but in Sketch or Figma or any other tool that is made especially for UI, you don't even have to bother. It's as easy as dropping this high quality bitmap into Sketch, then you can resize it down, and then you can export it in different scales. Okay, so now you know that you need to use vectors and high quality photos. Most of the time for the UIs, you will use vectors. And now let's talk technically about the formats that you need. So for the web, you'll go with SVG files or simple base64 code. So let's go to, for example, Illustrator. And if you want to export assets from Illustrator, you select this asset, and it's extremely important so that you have the artboard that fits to this object. And this is simply because otherwise you have some different size for this and it will be difficult to position it in CSS, for example. So you select it and you go to object, and then there is artboards, and you go to fit to selected art. And it's as easy as that. And now you can go to file and you can save as, you can simply save it as an SVG file. And for the SVG file, let's save it out. I'm going to replace this file. You can also see the SVG code here. And this is this base64. You can basically grab it and put it straight to HTML, and it will also render this graphic, and this will be always sharp. When you make it larger, it will simply re-render it, and it will be extremely crisp. But usually you just need to export this with its default settings and press OK. If you don't want to scale the artboard, you can go to the layer and you can export the layer with export for web setting in Illustrator. But this is the safe way. Inside of Sketch, if you're working in Sketch, it's as easy as selecting the layer or the group and making it exportable. And here you also have this scales that you can add, but if you are exporting vectors, you won't have any scales. You need to change the format to simply SVG in this case, and then you don't have scale, you have only one file, and if you export it, it will export only the selected asset. So it's extremely easy. Okay, now for iOS apps, you will use SVG files or PDFs. Those are all vectors, but for SVGs, you need to apply some additional libraries to your app. So this is not always possible, and you have to first contact your company, your developer, and ask if he or she can use this particular SVG libraries in iOS. And if so, you can provide SVG files, but otherwise you have to stick to PDF files, which are not all that good, but from Sketch you can easily export them. So if you select something in Sketch, you can go to the format and you go to PDF. Well, PDFs have some disadvantages, and they don't always go smooth when in terms of, for example, some shadows and strokes and so on. So if you can't really do it the other way and import this SVG libraries, you'll probably have to go with PNG files for iOS. So if you select PNG, please remember that it's best to use PNG 8 if possible to keep the file size smaller. But if you really can't, you go with PNG 24, that's default for Sketch. and then you have to export those different sizes. So you need to have 1x scale, 2x scale, and also 3x scale because you are exporting this. For Android, you will have something that's called vector drawables, and those can be exported and converted from SVG files. So you can find some online converters or some tools that will go ahead and get this SVG code and simply convert it into vector drawables that you can simply put inside of Android application, and this will work. And you can also work on SVG paths. You can use this data from the paths that you have in SVG file and encapsulate it into an XML description, and this will still work. So basically, SVG will work easily on Android, on web, and also on iOS if you have the proper libraries, as well as on Windows, because you have this XAML format there, but you can take SVG code and again with some converter, you can convert it into XAML. So this is pretty straightforward, and this might be a lot of information, but it's always best to confirm it with your developer, and it's always best to use vectors and this SVG data that you can then convert to, for example, XAML or vector drawables. The biggest problem is probably with iOS, where you have to use some external libraries, or you have to export PDFs, which are not perfect. So sometimes for iOS, you will stick to PNG files and export them in different scale factors. Two more things that I like to mention are icon fonts and sprites. You might have heard of it, and icon fonts are simply fonts that have icons inside instead of digits and numbers. And then you use those signs in order to display icons on your website. It makes sense. It is vector-based, but then you have to embed this particular font to your website or to your application. So if you want to learn more about icon fonts, you can check out the link that I provide. And also, one more term is sprites. And sprites are usually used in the web projects where you provide one, for example, JPEG or PNG file with all the icons for your website, and then with CSS, you move it around so that it displays proper icons. Well, this was really important when you created it with some older technologies, but right now with the newest HTTP and HTTPS standards, you don't even have to provide sprites because those requests to the server for each icon doesn't matter so much, so you can easily go with single files for each icon, and I strongly recommend you to use SVG all over the place in the web. Okay, next thing is that if you have to use bitmaps, use them wisely. So use JPEG for photos and then make compression. So if you, for example, have some photo in the background, then you can export it as a JPEG with some compression applied so that it's lighter. Then if you need transparency, you will need to use PNG files. And then I recommend you to use PNG8 whenever it's possible. But then if you need this 24-bit transparency, you have to use standard PNG files. And this will come last on my list. And if you are creating assets for higher density devices and you're exporting bitmaps, you have to also name them correctly. So, for example, Android and iOS as well as Windows has a special naming convention for the native apps. If you work with web apps and you export for the web, you can keep this convention, and then inside of your website in CSS, you can determine and detect whether this screen is, for example, scaling to 2x, and then you can load appropriate assets. If you create a native app, you will export with these suffixes as well, and the naming convention is, for example, in Sketch. And if you have these exported assets there, it will automatically add the suffix that is at 2x for 2x scale and at 3x for 3x scale. And this is the same name of the file, but then it has this ending, which is the scale factor. And if you have native app, iOS will automatically display the assets that are appropriate for the device, for the screen that it has. And it happens also for Android. The naming convention is slightly different because you have the suffix of dash and then the resolution. So you can put dash MDPI or XHDPI for some higher quality screens, and then this asset will be loaded and displayed so that it has the optimum quality. Also, you can do it for Windows with the suffix, and the suffix is scale dash, and then you have the scale, for example, 140% or 225%. And you can also, for Android and Windows, put it in the separate folders. So you have exactly the same name for the files, but you keep them in the folders that have the ending of dash, for example, MDPI for Android, and scale dash 140 for Windows. So it's pretty straightforward, but you have to remember about these naming conventions. So if you design UI, you always think of pixel as the smallest part of the screen, and it always comes down to pixels. But then you realize that there are so many different names for pixels. For example, Android uses DP for pixel, and this is called density pixel. And then iOS uses PT, which are points. But then again, it's all the same if you work in 1x scale. So it's another argument for 1x scale, because if you start working in 2x or 3x, then those point values and DP values will be different than pixels, and you will get it all confused, and you'll have to convert values, divide them, or multiply. And if you work in 1x scale, it's also simple, because 100 pixels will be 100 density points and 100 points for iOS. And then you have this special values for text sizes. Those are scale independent pixels, and this is also for Android, and this is SP, and this is also the same as pixels if you work in 1x scale. So 16 pixels in 1x will be 16 scale independent pixels, so 16 SP. So you have to use it in specs though, because it's so much easier to provide those numbers to developers so that they know that you have 20 DP instead of 20 pixels, okay? So if you hand off this to the developers, you for iOS use points, and for Android use density pixels and scale independent pixels for text values. And it's always better to understand the physical size of the assets if you provide those values, because you always know that it's approximately this kind of size on a device when you have, for example, 100 points. So it's another argument, and it's worth to remember. So some final takeaways from this part are that you ignore devices when designing. So you don't really design for iPhone 5 or iPad 2, but you design for this specific device range, for example, for phone, tablet, or desktop. And then also you ignore PPI completely. So as a designer, you always think about scale factors. You design in 1x, then you export to 2x, 3x, 4x, and you don't have to know that 3x is, for example, above 300 dpi. It doesn't really matter, because you have all assets that are vector, and then you can export to any size, and you can focus on these safe numbers, which are 1x, 2x, 3x, and 4x, okay? And then you have to always use vectors if possible, and if not possible, so if you have photos, you have to use great quality assets. And then in Photoshop, you use smart objects, and in Sketch, Adobe XD, or Figma, you simply put those photos that are high quality, then you scale them down, and you can export in different sizes. And one more takeaway is maybe not to use Photoshop at all to UI design. And in the meantime, I've showed you how to export assets from Illustrator, Sketch, and even Photoshop. And please also remember, as a bonus tip, that it's worth to use a grid. And for example, in Sketch, you can go to View and Show Grid option. You have a grid here, and the best grid for optimum quality of your assets is 8-pixel grid. So it divides for most devices, and it works really cool with those absolute values for pixels. So I will explain this in detail in next courses, but remember, it's worth to use 8-pixel grid as well. And then there are also some device or platform specific issues that you sometimes need to take into account. For example, if you take a look at this chart, those are all the iPhones, and For iPhone 8 Plus, for example, you have the point value here. So this is the row where you have the 1x scale, and then you have rendered pixels. So this is the native resolution. So this one is scaled at 3x. So you have this kind of resolution, but then you go and downsample it to full HD. So you have more native pixels inside of this iPhone, but then it downsamples them, and this is a specific case in which you might not have the perfect pixel values. But still, it's going from bigger value to slightly smaller, and you won't even notice this in this 401 ppi screen, which is very high density. And you can see that iPhone 10 is 458 ppi. So you can compare those charts for iOS, and also you can take a look at Material Design Device Metrics website, and here you can see all the different devices with Android and also some iOS devices. But this is pretty nice because you can see the device type, and also you can see the screen dimensions and the aspect ratio that you have. And here you have the density points, which is a 1x scale, and there you have the native pixel values. So for example, you have full HD here, and then the density here is 3x. So it's XX HDPI. So if you take this value, which is native, and divide it by density, you will get the 1x scale, which is in DP values. Okay, so this is how it looks for Android. And basically for the web, you are safe if you export 1x and 2x assets. So if you have 2x assets, they will be suitable for example, 4K and 5K displays. And I believe for now it's enough. Now let's talk about one more type of assets that you might be willing to create, and this is especially for native apps, so for example for iOS apps and Android apps. And those are stretchable assets. So if you have a background for your app, you sometimes want this background to scale horizontally or vertically, and for example backgrounds for buttons and other assets can scale as well. Then for example, if you have this kind of button for iOS and you want it to scale horizontally and vertically, you can create an asset that looks like this, and then you can determine that those lines will scale it, the middle point will be scaled horizontally or vertically. And all you have to do is export this kind of asset and tell your developer in the specs that you want this to be scaled horizontally, for example. And then it gets complicated in if you want to create this kind of assets for Android, because you have this concept of 9-slice scaling. So for Android, basically, if you want any asset to resize, you will create a file that has a special naming convention, and this is .9 before .png, before the extension. So you put .9, and basically what you do is also you put a 1 pixel line, which is of a black color, next to the edge that you want to expand. So you might, for example, left out rounded corners, and then you put this 1 pixel horizontal black line next to the left edge, and it means that it will expand horizontally according to this line, and also it will expand vertically according to the top edge that you can add. And then you simply save it as some file.9.png, and it can scale seamlessly in Android assets. Next thing I like to discuss is aspect ratio, and I want to make sure that you know this term. Well, aspect ratio is pretty simple because it is the relation between width and height of your device. So, for example, iPad has some different aspect ratio than the other devices, and it has 4:3. And other devices usually have 16:9 and 16:10 aspect ratio. Also, you might account this term that is called responsive breakpoint, and this is in terms of responsive design, so designing layouts for the web. It means that you have some breakpoint, and this is a 1 pixel that causes your layout to change. So you can decide that in this particular pixel, your layout will shift, and for example, you will hide some columns in the layout, or for example, you will reorganize the assets that you have on your website. And this responsive breakpoint depends entirely on you, because you basically don't have this standard resolution for screens, and you have to create a website UI that scales seamlessly across multiple resolutions, and from the smallest one to the biggest one. But then you decide on the breakpoints to break your layout and reorganize things. And also for responsive design, you will start with a smaller screen and you will design for mobile first, then you go to tablet, and then you go to desktop. So you need to check out those three resolutions. But then in the mean point, you also need to put some breakpoints to ensure that your layout scales seamlessly to all of the resolutions. And also you have the easy term of orientation. So you basically can have the landscape orientation, which is this way, and portrait orientation, which is this way. So it's pretty straightforward, okay? Now, another term is screen refresh rate. For the screen refresh rate, you usually have 60 Hertz, and you probably have heard of it. And this is very easy because it's like frames per second. So your display can refresh at 60 Hertz rate. It means that it can display 60 frames per second. And this determines that you have smooth motion when you create prototypes, when you create animations, as opposed to, for example, 24 frames, which is kind of lower amount of frames in between, and it can become jaggy, and you can see this motion is not entirely smooth, but when you have 60 or more, you probably won't see the difference. So this is about the speed that your display renders frames per second. And if you have, for example, 60 and you create your animation with 120 or 200 frames per second, you might even not notice the difference. And this is simply because your screen doesn't have so big refresh rate, okay? Now, this is not entirely important in screen design, but in case you were wondering, this is how it works. Now, one important thing are touch targets. And you have to always take into account touch targets if you are designing for touch-enabled devices. But for future projects, I strongly recommend you to think of touch first, because probably in future all the screens will be touch-enabled. So on the desktop, you have mouse, which is extremely precise, and you can click directly to the very pixel you want. But then you have touch-enabled devices, and your finger isn't that precise. So you have to take into account creating assets, and especially buttons and some interactive elements that are slightly bigger for touch-enabled devices. And for different systems, you have different specifications. For example, for iOS, the minimum touch target is 44 by 44 points. Then you have 48 by 48 on Android. And on Windows, you have the size of 9 by 9 millimeters. And this actually is about 48 by 48 as well. But then you have some recommended padding as well of 2 millimeters, and totally you have 60 by 60 points or pixels if you design in 1x scale. So it's from 44 to 60 pixels, but still remember, you have to keep it slightly bigger so that it's touch friendly. And if you want to read more about touch targets, I encourage you to take a look at the link that I have here. And one last thing I'd like to cover in this video are some color considerations. Well, this is a vast topic and I could talk for hours about colors and color management. However, for UI design, it's pretty straightforward. Well, the truth is you can't work in such a way that everyone sees the same colors, because everyone has different display and different display settings. Actually, one tip that I can give you here is to depend entirely on sRGB color mode instead of going for some greater color modes like Adobe RGB or ProPhoto. You might have a nice display that's calibrated this way, but no user will see the colors that you design in. And this is simply because most of the current displays have this sRGB coverage, and that's so you have to stick to sRGB. And then if you work in Sketch, you can skip this part entirely because Sketch basically doesn't manage colors. And if you work inside of Photoshop or other Adobe software, I strongly recommend you to turn off all the color management done with Photoshop to have your display calibrated or emulate sRGB color mode. And then if you export the assets, for example, from Photoshop, don't select to include ICC profile, because it makes the file larger, while the specs from W3C are that all the browsers should display this color mode that is sRGB. Okay, and that's all for now. So thank you for your attention, and I hope this was meaningful and you've learned something new. So if you want to explore those things in detail, I encourage you to check out the other courses. For now, that's it, and I see you in the next videos.